substrate already support running multiple consensus protocols, right?
Yeah, you can grow your own consensus, and you can have parent chains, okay, that are combined with grandpa.
I see. Hi, Joshy.
Hey, everybody.
Hey, Joshy, nice to meet you.
How you doing, Rich? Good to meet you face to face.
Very well, thanks.
Great.
Sorry, Jim.
Hey, morning. I was just saying my aim is, peer-to-peer network running in the browser, doing transactions in Rholang and sort of coordinating with the parent chain, which includes our chain. Okay?
Oh, I see.
Yeah. It's an easy way to integrate Rholang, in that you can, from a WebAssembly application, you can call, you can do an API call and get a result. And so we could call our, we could make calls to our node, or what I see as being the intermediate GraphQL interface that handles the caching and gRPC interface our chain. But I'm also thinking about how your technique, Thomas, of sending gRPC between calls, between nodes, could enable an implementation of sharding, that's sort of independent and would allow evolution of sharding technique.
And I'm wondering, yeah.
And I see this important distinction between the local and the global, and what's in your neighborhood having a consensus that's like local time, Earth time.
Yeah, I'm wondering about synchronization. If we have like a sequential machine communicating with a synchronous machine, maybe the synchronization will be too big to,
Yeah, there's a number of problems, and we probably should let Joshy get started. But I definitely like to talk more about really decentralizing the computing, being blockchain agnostic, so to speak, but still having a Rholang environment that you work on and a local consensus mechanisms in the various localities that you participate in.
Yeah.
Were you talking about? Sorry, were you talking about substrate just then, or just generally?
Substrate, yeah, but more generally, I also would like to put Rholang on holochain. I think it has a place in the ecosystem as well.
Fair enough. Thanks.
Yeah, Jim, I love the idea of thinking of Rholang not specifically as being smart contracting for our chain, but just as being a super nice way to express programs that, maybe lives on our chain, maybe has runtime environments on other chains, or, like some of the examples we've talked about, even just being off chain entirely, just being a programming language.
Yeah, I put in the substrate channel sort of my vision of how we can coordinate these remote channels, and it's the idea of having local channels and global channels, and then maybe cosmic channels. Okay.
Yeah. Yeah. Why assume that global is the top, right? It's got to be multiversal.
I'm wondering how many of you have listened to Greg's latest Rcast?
About Rholang 1.1.
About life.
Yeah, it was part 2 of that Towards a Living Model.
Yeah, this stuff is pretty heavy, and it's, I think it's sort of like the excitement we all feel in the background of all the possibilities that we're opening up. And, sometimes I think Greg gets a little bit too far ahead of himself in terms of, how much the math turns out to be utterly simple, but the devil is in the details.
Well, I've listened to that thing about 4 times now, and it is full of I'd at least call it brain candy. I mean, if you've got any free time, I think you will enjoy this thing. Thomas Love and Jim, what do you make of his take on these towers, towers of space times, but he brings it more down to earth when he talks about towers of virtual machines. And I'm wondering, I feel like where he is going with this is very important, but I can't wrap my head around it yet. Do you have a feel for what he's talking about here?
Yeah,
Go ahead, Thomas.
No, please.
What I see is, like emergent order from the molecule to the organelle to the cell to the being to the planet to the universe. The chemical layer, the atomic layer.
You're trying to talk about like self-similarity across orders of magnitude, different sizes?
Yeah. Different degrees of locality.
Yeah, he talks about these levels, lower and lower levels of and I think Jim's right there. These are levels of locality, and I'm just wondering, what is the program? He talks about levels of locality within Rholang virtual machines.
Yeah, and it's different. Difficult to, I haven't figured out how to do it yet, but it's like watching the watchers. It's these constraints or
Is this idea related to Rholang 1.1, or is this a different idea? I just saw that Jim posted, or somebody posted the slides called Rholang 1.1.
I don't think so. I looked at what's going on with 1.1, and it seems quite reasonable. But I don't think it came out of Greg's thinking in these last 2 series of Rcasts, and this is all tied to, for me, it all started back when he introduced the error correcting code as a solution for finality.
I see connection in a second.
Yeah, go ahead.
I see connection in a sense that this is optimization to acknowledge the message. So we need some kind of overhead to apply error correcting codes. So this overhead can be like a slower machine, but with this I see like a performance improvement that can be a benefit to these extra messages.
That rings true as something I read as well. Firstly, is this towards a living world RCast, Gary?
That's correct. Yeah, part two of it is the one I'm most interested in.
I'll take a look at both. Just a couple of comments on that. I was reading about because I'm aware of. I don't want to get into the details. So I'm a newbie here, but I'm aware of the split with Pyrofex, and that Mike's staying that looking at C Delta. And I read an article that was critical of a Casper proof of stake consensus mechanism on our chain, to which Greg did reply.
Did you read incorrect by construction?
I didn't.
Oh, okay.
Is that worth Googling or?
Yeah, it's more of a blog post, but it gets at the gist of that criticism, I bet. Yeah, I'm not sure which article you read, but if it was from the Pyrofex guys, it's probably the similar kind of theme.
Got you. And I think I read a riposte from Greg along the lines of, we can handle that, it won't slow the network and get in loops, and we can basically handle it through error correcting codes, which I think might touch on what you guys have just talked about. And then just from my maths background, I really don't know what a tower of virtual machines is. I haven't looked at the article, but it might be worth Googling Hausdorff spaces, which is topological spaces off which chaos theory is built, because it sounds like fractals and that kind of thing, just from what you said, Joshy. So I just thought I'd throw that out there and see if anyone wanted to either ignore that for now or come back and make a comment whether I might be on the right lines.
Yeah, fractals is perfect. Also, a lot of this depends on use of reflection, and which enables
replication, right?
It enables, well, very primitive, in a primitive sense. It does, but it's really about being able to observe a system of processes and affecting it. I believe I could be, and I think as Rholang programmers, we've all been challenged to some extent to utilize reflection effectively in understanding the state of a system of Rholang or whatever.
So
there's a gap there, and I see in actual implementation of many of these ideas that Greg is showing are possible in this framework.
Well, this idea of the towers of interpreters, I've run into this before, and Greg even pointed at some of the literature around this. I kind of have a handle on that as as a programmer. I kind of see what's going on there, but we're talking about now in a concurrent distributed programming language. What is, I'm just wondering, what are the implications there for the programmer? What are we to make of it? Is this just a toy, a novelty that Greg has observed in passing, or is it indeed more important?
I think
Anyway,
there's some excellent articles that about code should eat code, which I don't know if I can find, but the idea of code as data and being able to use that capability, I think, is central here.
Yeah, and I've seen that video, and I was thinking of another of her videos in my own understanding of these towers of interpreters. But you know, I'm just wanting to, you know, I'm trying to get a better idea, so I feel a little comfortable going down layers in my Rholang program. I think that's where Greg is going with this, but I still don't know what the implications are for concurrency and you know, or you know, what does this mean to us? And I don't think, I don't think this is precisely 1.1. I see those as just being almost optimizations of you know, the grammar itself, but not for the reasons that were started with the error correcting code.
Yeah. But this is not only about the grammar. These extra acknowledge processes are not written to tuple space, so it is like a performance benefit.
You guys want to look through that spec? I've only looked at the first few slides. Did you read it?
Yeah, sure. I was watching the Greg's explanation.
Oh, when did he explain it?
On Casper stand.
Oh, on Casper stand. Oh, that's a weird place to explain it.
Yeah.
Cool.
I was totally surprised. You know?
Is it worth looking into?
Oh yeah.
Okay, cool. I'll.
You will definitely love it because there is a let statement now.
Oh, I do love that idea. So I looked at this part already. So he says improved for comprehensions, and so some of this looks pretty similar for some pattern from some channel, and then he said the and is the new syntax for join. Yep. So we're like joining a bunch of things together here. So what's the semicolon then? Sequential, like receive this, then receive this, then receive this.
Yes, after you receive this, then you must receive this.
Okay, cool. So in general, these could all be like, this could be some things joined together, and only once we've received all of those, then we go on to the next join. And I guess those joins could be single receives in the limiting case.
Yeah.
It's far preferable than having a whole bunch of nested fors and intermediate variables that you don't need.
Totally. Yeah, stuff gets so deeply nested when you have to do all of those fors.
Mm.
So oh, and so the things that we could send here, okay, so source is either just a channel or one of these things that he's going to explain in a second. And I didn't get to this one yet, but is that also coming up in the next couple slides?
Yeah.
Okay.
This is like a different way to create this hidden channel, hidden acknowledge channel that will be passed to the caller.
Okay. So this one, the question mark, the like receive send one is.
Yeah,
so,
I didn't get it. How he called this?
Oh, what did he call it?
Sure. I'm not sure. I didn't understand it. So.
When I punctuate sentences like that, it's when I'm like really surprised. So maybe we could call it like the surprising channel.
Yeah.
So wait on X for a tuple where V is the normal thing that's going to get subbed into the continuation, and R is a return channel. And it just sends, I guess it sends nil on R. This is as far as I got before we pulled this up.
Yeah, and this is not really nil. This is just acknowledgement. I'm not sure what is the difference, but Greg mentioned that there is a difference. So.
Oh, that's interesting. Okay.
I'm not sure.
Yeah, for a second, this really started to remind me of the synchronous pi calculus, where you can have continuations on sends.
Yeah. Maybe this is like very, very similar to that. I mean, maybe it's the same.
Yeah. Okay, so let's look at this one then. For some pattern with this special syntax from X. Oh, it desugars too. Oh, R send. Oh, this. Yeah, that is different than nil.
Yeah.
The decorations are mnemonics for the fact that the expression waits on X and then sends on. Okay, that makes sense. So we're just enabling this like invisible, or not totally invisible, but like more convenient acknowledgements to go back.
Yeah, and this R channel is not on the tuple space, so it's.
Oh, it's not in the tuple space. Well, what's the point of it? Like, who can listen to it?
No one. You just want to acknowledgement that your message is received, and you want to execute continuation. That's it.
Oh, there really is a continuation.
Yeah, because you want to execute P, but you want to execute your P after the sender received the message that you received.
Yeah. What does the sender get to do when they receive the acknowledgement, though?
He can also. There is a dual to this, so you can when you're sending, you can automatically be aware when receiver receives.
Dude, this is totally the synchronous calculus.
Yeah.
Okay, cool. So let's see. So this is the other one now. Wait. Which one's which? Oh yeah, this is the other one. The exclamation points first. So means send on X the augmented argument list. Oh yeah, just all of these arguments plus one more, the return channel. And then wait on R for a response, which will be pattern matched against. Oh wow, but it's okay. Hold on a second here. It feels like the synchronous calculus. It's still written with a 4 though, I guess. What are we pattern matching against this pattern? And then wait on R a response, which will be pattern matched. Because I'm just thinking, I'm wondering who gets to send on R. Oh, so maybe is it the case that like this new special thing doesn't have to be paired up with this new special thing? Like I could do one of these kinds of special sends here, and then the person receiving can actually send like interesting structured data back on R?
I don't think so that you can send something on R because you don't have access to on R.
Yeah.
But you're waiting on R.
Yeah, whatever comes back on R is going to be pattern matched against whatever pattern you put here. Before executing the continuation P, and I assume that we would substitute bound variables into P then. So that's a little bit different. With the synchronous pi calculus, you don't actually get to make any substitutions into the continuations that happen on sends. I think the substitution only happens on the receives, I guess. Okay, so let's look at one here. So for some pattern, send this stuff plus R and then do P. And so he says it's the same as making a new R, sending all the same stuff, including R, and then waiting for something to come back on R. So that seems like if it really was this, then I could just par in my own like for something from X. And if I, pattern match the right arity here, I could extract R and send anything I wanted on R.
Oh, but you will not see, I think that you will not see R in the pattern.
Okay.
I'm guessing. I'm guessing.
Yeah.
You will probably.
I think my working hypothesis is that you can see R, because otherwise I don't understand why we would be pattern matching. Because like if the only thing you ever get back on R is one of these little special things.
But I think that you're pattern matching on the Yeah. I was thinking on the arguments, but you're sending the arguments, so you.
Yeah. So let's see. Okay, so thus the decoration send receive are mnemonics for the fact that the expression sends on X and then waits on the return channel R. New and improved for comprehension desugared. So this is, I'm guessing, the same thing that he already said earlier.
Oh yeah.
We make a new R11 and we send. Oh, this is one of those sends. Oh, wow. You can combine them with joins. So I can do one of these, like, send all of my A1 to AKs and, like, then I'm joining on the response that's coming back from R. And maybe this could just be like a regular old receive or the new kind of receive that receives and then sends an acknowledgement.
Yeah. And what this means that after you receive the acknowledgement for all your joins, then you will proceed.
Yeah, right.
Okay.
Oh, so join is this and, I guess. Was there new vocab for how we pronounce this semicolon? And then?
Not sure.
Okay. Oh, one of them was for the send receive. This one's for the receive send. So this is the one where you first listen and then send the ACK. And
so you're listening, and after you receive, you will send acknowledgement on this R, right?
yeah, that seems right. So we only have to explicitly write that we're waiting for this pattern, but then implicitly we're actually waiting for a slightly more structured pattern that also has R in there. And then after all of this stuff happens, then we send the ACK and do whatever P was.
So the pattern is really like a regular pattern. We are just,
I think so.
Waiting on this channel, and that's it.
Yeah, I think so.
Okay.
And R is fresh for the whole context. Okay, cool. So here's another one. Oh yeah, go ahead.
Sorry guys, I've just noticed he's put, I have no idea what a lot of this means, although I am listening, but removing recursive sends. That line sounds potentially important in the context of what Gary was saying about
I think
towers
it means
of things.
I think the RECV
okay,
is
fair
receive.
enough. Thanks for the clarification. Okay.
Yeah, no problem. So Rich, I saw you saying you had looked through some of the like that code snippet that I posted last week and maybe a hello world. Do you want to talk like some Rholang at whatever level you're at?
Maybe another time, definitely.
Okay.
Thank you. But I think cool. This is, I've never studied process calculi, but I have done quite a bit of, well, no, not quite a bit, but I've mastered the basics of logic programming and wrote a Prolog program. So I get the kind of the equivalence between the two and the sort of thing this is about. And I think just please continue this session, but another time it'd be great to do something a little more basic. But I'm getting switched on to what the PyCalc and the RoCalc is through Jake Gilsberg's lectures that you attended. Oh,
good. I'm so happy you heard it. That's exactly what I was going to recommend.
Wonderful. I'm up to the start of the Rholang one. I've done the PyCalc once. This isn't totally unintuitive, but yeah. Thanks for the interlude. I'll let you get back to it. Cheers.
Yeah. Okay. Yeah. Cool.
If you're available for the 4 p.m. New York time work study today, we will be doing some more basic Rholang.
I may be. I've promised to help my dad do a crypto investment. So nice. Once, if I finish that, I might try and tune in. Thank you.
Where are you at, Rich?
I'm in Spain on holiday at the moment, hence having a bit of time, but normally London.
Oh, okay. Okay, cool.
Yeah, and you're in Berlin these days, Joshy, is that right?
Yeah, for one more week. Yep.
And then back in the US.
Yeah, I'll be back in Eastern time, Eastern United States time then too.
Cool. Well, enjoy your week. Cheers. Thanks, guys.
So, okay, so sequential output allows for sequences of sends. Yeah, okay. So I was thinking at first that sequences of sends didn't make that much sense because you just send it and forget it. You never really, like, no one else would be able to tell what order they came in anyway. But that's not true if we have these ones. Oh, maybe this is the whole purpose of these things.
I see this like a dual to receive, because now you can send and wait for this R.
Yeah.
And then proceed to after the semicolon.
Yeah. I'm trying to think of a use case when I would want to send and make sure that send got received before I do my next send.
When you send something and you want to and you are sending also the acknowledgement channel just to receive nothing, just
yeah, we do that all the time.
Yeah
I'm thinking of, like, for some reason it seems like when we write some like cool little contract and then we write the tests to make sure it works, it seems like we're always doing that there, like there's a bunch of setup phases or something. Yeah. Okay, cool. So that makes sense. So it sends this. Oh yeah, go ahead.
I just want to say that this dot at the end, I'm not sure why it's needed, because you have semicolons and you separate all of these sequential things, and now at the end you must put a dot. So in a sense, something else will be later. So we know this is the end of the expression. So I'm not sure.
Oh, maybe this is the you remember in Milner's tutorial, like technically PyCalc terms should always end with .0, maybe, but like sometimes we omit the .0. I wonder if that's what this is.
Yeah, exactly. This is exactly. Greg was saying exactly the same thing.
Oh, cool.
But what on the receiving side? There is not dot on the receiving side, right? When you write the form.
Oh yeah. Yeah, right, because you're saying this dot is like exactly the same as like just writing nil, for example.
Yeah, the semicolon nil, semicolon nil. Yeah.
Yeah, right. Yeah, it would be nice to have that same kind of sugar, I guess, on the like when all you want to do is receive a message and discard it. You mean?
Oh, you mean a dot everywhere when you want to, like a par with the nil, or?
Oh,
are you talking about that, or?
Well, I was let's just do this. So right now we're looking at something like this, where I can do like Xbang. Whoops. So let's say we wanted to send like 4 on channel X, and then we wanted to send 5 on channel Y, and then we finally wanted to oh yeah, I don't know. I can't even think of what I would put in here because I don't have any experience programming this way. But maybe it would be like, oh well, maybe this is just like setting up environment. Maybe this is like let X equal 4, let Y equal 5, and then like
yeah, maybe you're sending information to multiple parties, and you want to be sure that everyone received, and then you.
Yeah, that but this seems like not quite the right use case for what you just described. So like if maybe I'm sending like, a piece of information to you and another piece to Gary and like a piece to each of you guys, and then only if all 4 of them have been received, then I want to continue. But I would almost do that like, so Tomislav, I send you whatever I'm going to send you, and then I send Gary whatever. And then like, let's just say there's, 3 of us, just to save some time. And oh wait, I would almost do it like this, like one of these acts. Anyway, what I'm getting at is then I would wait on it as like from act and join it. And I guess this is the new join syntax, and then carry on. And I wouldn't want, because I can still do all of these, send a message and wait for the act concurrently this way, as opposed to here I'm like sending one, waiting, sending one, waiting for the act, sending the second, waiting for the act.
Yeah. Definitely want to do it in parallel, not to wait.
Yeah. But I there must be some kind of case where this is useful, like, man, I don't know, like build the foundation, then build the ground floor, then build the first floor or something.
Yeah. I'm thinking that maybe you can send some more complicated process on which you later do something, but yeah. But why sequential? Not sure.
Maybe what if this is like some kind of game factory, and we're sending our own, like, what would it be called, like player control. So like I'm trying to think of, like, I want to play this game, so I call up the game factory and I send in, this is going to end up being like basically an object capability. I can like take turns on it or quit the game or whatever, like, and I'm protecting the scope of this thing because it represents my ability to like make my choices in the game. And then like only if the game is initialized, then I want to I don't know, like whatever my move is, and then finally something. But so we were talking about this dot though, and I was thinking about, imagine if I wanted to like for something from Chan 1, and I just want to receive it. Like, I don't really know why. Maybe because I'm a bad guy and I'm just trying to interfere with messages going somewhere, or like, I'm not sure, but it would be interesting if there was a period there.
But I think that you still need to make a par after the dot.
Oh, before I go on. Oh,
yeah.
Now this is valid program. This whole thing is a valid program.
Yeah, and in that sense, I'm thinking that this dot is not exactly the same as you writing inside the for. When you write semicolon inside the for, you're not putting dot at the end.
So you mean the old semicolon for join, or the new semicolon?
New semicolon.
Okay.
Yeah, new semicolon.
yeah. That's a little unfortunate, I can tell already. So something like this, you're saying? Oh.
Yeah, and after channel 3, you don't have a dot.
This one, yeah. So what would that mean? Oh, because this is like the sequential sends, and you can end with a dot. This, you're saying, this is like the sequential receive.
Yeah, exactly.
Oh,
without dot.
Yeah.
I'm starting to see why is this why is this not the same, or I'm looking the wrong way.
Yeah, that's a good. I mean, so we certainly can express what you want to express this way. Or is that what you wanted to express?
I'm just wondering about the syntax. In a receive, you don't need to put a dot at the end.
Yeah. Well, I think here you don't need to put the dot either. We can always just put like the continuation.
Oh, you cannot put continuation here.
Oh, you can't. Oh, how about like that though?
Yeah.
Yeah. So it seems like the dot is almost just syntactic sugar for like, and the continuation is nil.
Yeah, exactly.
Yeah, right. Okay, right. So it would mean the same thing here, right? Then I don't need to put this.
Well, I don't think that this is after the parentheses. So I see this as a replacement for another binding inside the for, inside the parentheses of the for.
Inside this one.
Yeah.
And I've Greg made a distinction between sending a nil and sending nothing. I'm wondering how that's important. if that's important,
Yeah.
or if that means anything. I mean, we could send anything, right? So whether we send nothing or a nil, it's
Yeah, it almost, I mean, so I wasn't there definitely. I always thought of nil as being that special value. Like when I wrote up or, drafted the Libro style guide, I was suggesting that if you're just sending an acknowledgement that doesn't mean anything else, then you should always send nil. And it almost feels like that's what this scenario is for.
yeah. That's why it surprised me when you sent an empty tuple.
Oh, is it the empty tuple? I didn't take it that way. That would make, I mean, that's how you spell like unit in a bunch of other languages. This one is what you're talking about, right?
Yeah.
I took that as like when you do a send, we always have to do like Xbang, whatever. So I took those parentheses as being these parentheses here with like literally nothing inside of them.
Right, that's an empty tuple, right?
No, this is sending the empty tuple.
If this is valid code, I'm not sure.
Okay,
Yeah.
my understanding was that we always sent a tuple, but I guess that's not.
Oh,
Yeah, this is like confusing.
good point. Because we have like those polyadic sends are like tuples. So maybe we're sending a polyadic send with arity 0. Is that what you were thinking?
I mean, certainly the list, it's not a list we're sending. We're sending a tuple, right?
Well, I've been grumbling about that for a long time, but in current Rholang, there's a difference. This is what they call a polyadic send, where I would do like, on some channel send 3, 4, 5, and then this is sending a tuple, where I do an explicit tuple.
Yeah.
Yeah. So in current Rholang, or actually, I haven't really tried a new node in a while, but I think in the latest Rholang from the co-op, these are different things.
Oh yeah.
Oh, we could make a test.
Yeah.
Oh, they are different. They're definitely different.
Yeah.
What was the first one? Free. I get the explicit tuple, but the polyadic send 3, 4, 5. Is that free element?
It does the same thing. Like I don't think you can communicate anything different here. It's just a matter like, yeah, I mean, I get why one would want to send multiple values in the same way that you might want to call functions with multiple arguments, but I think tupling is probably a good way to do that. So yeah, if your question is like, what was the motivation? I'm not really sure.
Yeah,
but Rich, differences on the receiving side also. On the receiving side, you put parentheses when you receiving a tuple.
Yeah.
And when you just receiving multiple arguments, you don't write parentheses for a tuple.
I see the difference.
Yeah.
So is that line 9? Is that sending to 3 different channels, or?
It sends all 3 of these values. It sort of packages them up and sends them as a unit on the one channel R.
That makes sense, but but in a way that is subtly different to sending the one tuple 3, 4, 5.
That's right.
I'll leave it there so you can carry on. Sorry.
Yeah. Well, there's nowhere else to go from that anyway. That's kind of just the end of the story, I think, about tuples at least.
I seen Mike's code, and he just wrote without parentheses. When he sends only one value, he wrote without parentheses, and this makes sense for me.
Yeah.
You just put a bang, and I'm sending this. And if you put parentheses, you send a tuple.
Oh,
it's not completely the case.
I had the great thought of listening for dot args, and then accessing args.end, which probably I'm sure doesn't work.
Yeah, well, it's funny because like with lists it works. So if you wanted that behavior, you could send a list as your argument.
Right. And
Yeah.
it works with tuples also.
So Tomislav,
It
you were
works for
saying,
tuple.
oh, does it work for tuple?
According to
Sorry?
it's on your cheat sheet, Joshy.
Oh my goodness, that does not mean it's correct, although it certainly meant I thought it was correct at the time.
I didn't notice that.
Wait a second.
There. Oh yeah, it is.
Where at?
Where?
Under tuples.
This one?
Yeah. And right. That's what I mean. That's
Oh yeah, you're saying to grab out a specific item from a tuple.
right. But could you make a pattern args and then pull the things out was my question, but I don't know.
I don't think you can in the current implementation. We could maybe try it though. I wanted to just follow up real quick. Tomislav, I remember a while ago you were talking about doing something like this.
Oh yeah, yeah.
You're saying Mike Stay wrote code that way too?
Yeah, yeah. And I'm not sure exactly where I seen it.
Yeah, I like it. I think it's a great idea. And then this is what means sending a tuple. And then this means sending a tuple that has one unit, which is itself a tuple.
Yeah. And yeah. I'm not sure if you write this in this way that we can just ignore this other surrounding tuples.
Yeah. Yeah, that would that would be interesting. I almost feel like making every parenthesis have an explicit meaning is best, because otherwise you have those rules about they're convenient to whoever knows exactly how they work, and they're just a huge learning barrier to everybody else.
Yeah, yeah.
Okay, cool. What should we go to? Where'd those slides go? Removing the semicolons. Oh, sure. It's the same as nesting the fours.
Oh, yeah. Yeah, yeah.
Sequential output allows for sequences of sends. Oh, wait. I must have scrolled back up somehow because we already looked at this slide. Sorry about that. Sequential send expressions desugared. So X send V, then do P. This is not, I think he meant to have a question mark here after that exclamation point.
Yeah, yeah, you're right.
New R in, oh yeah, so we send the tuple and then wait on the tuple and then do, oh, so we can't extract any information about what comes back from that because it desugars to this thing that never binds any names.
But how we get V? Oh, no. We are sending we we will receive someone else. Yeah.
Yeah.
Okay. Yeah.
So but I guess so let's say we do one of these things, this Xbang V, the person who's receiving that on the other end doesn't need to know anything about whether we did that kind of send or not. Like the interpreter is just going to automatically give us back an ACK that they don't have to worry about.
Yeah, exactly.
Yeah.
But are you saying that on the other side we need we need to use this special receipt, right? We cannot just.
That's not how I'm interpreting this, but that's a really good question.
Because I was thinking that you are asking, can we just ignore this acknowledgement and just be a normal receipt?
Yeah. So let's say we have a program that looks like this, where we make a new channel and then we do one of these new special sends. Oh, I need a continuation now, or I'm allowed a continuation now. So whatever it is.
But how you mean a semicolon, right?
Oh yeah, yeah,
Okay.
that's right. Yeah. Oh, and I guess probably the standard would be to do it like this.
Oh yeah. I was just-
Got the ack. Okay. So then like over here we have something like for, you know, Val from Chan. And then we are gonna, I mean, I don't know, it could be anything. Val was, and then we'll just pretend like this syntax would work. So I was thinking that this would be acceptable under the Rholang 1.1 spec. But you're saying you think it has to be, if I want to com with one of these special sends, I need to have one of these special receives?
Yeah, I'm wondering. And if you use these special receives, what do you do then? You say Chan.
Yeah, what did the syntax even look like for those? Like I already, oh, here's one. For pattern from,
so
you know,
this is just at the end of the channel name, right?
yeah. So what, oh yeah, what does this mean again? When I do this kind of special receive? He says it, oh, it means I'm going to send, wait, what the hell? It means I'm
after you receive, you will send acknowledgement.
Okay. But, yeah, maybe you're right. Maybe they do have to go together.
Oh yeah, because you have a semicolon when you're sending. So you will not progress until you receive acknowledgement, right?
Yeah.
So you need to make this special receive.
Well, okay, so where did he? Yeah, go ahead.
Is this therefore introducing a degree of synchronicity between channels or whatever, which might help when you don't want to be asynchronous? Is that why we're getting the receipt back?
That's that's the idea, definitely.
So it might fit in with the sharding in some way, or maybe not. But
I think it's just a matter of synchronization.
Yeah, I'm happy with my first statement. Let's leave it there. Thanks.
The silence only meant that I'm not really sure what the state of the art on sharding is.
Fair enough.
Yeah.
This is really fascinating. Cheers, guys. Carry on.
So where he was saying desugaring, oh, we were not that far. Where was he desugaring the sequential sends? Because okay, we had this code over here, right, where we're doing the send and then wait for an ACK, and I thought he was saying that the top part there desugared to. Well, let's see if we can come up with it. Chan send 5, comma. Oh, I thought it desugared to this, right? So, and then we send star ACK here. And in parallel with that, then we're going to for
unlock. Yeah.
From ACK. Yeah. Then, then we're going to do the continuation.
Yeah.
Yeah. Or whatever the continuation was. So if it literally, if it's truly desugaring, like it means writing this is the same as writing this?
Well, it's not completely the same because this ACK will not end up in tuple space.
Oh yeah, you're right. It's definitely not completely the same. Yeah. Okay. Yeah. So maybe I think you're right then. I'm coming around and thinking that they have to go together.
Yeah.
So okay. Does that mean then? Yeah. Go ahead.
The main difference that I see there is that all the following code would need to be well, inside the braces, I guess that's still the same, but seems like you're the main thing, besides, I don't know, it's making the code a lot more comprehensible.
Yeah.
Without a million nested blocks.
Yeah. Yeah, I'm curious, like, if someone wrote this exact code that I have here, well, and maybe actually pulled in standard out the right way, would we have a COM event? Because it sounds like maybe not.
Yeah, because after you receive this val, so you cannot receive val if you not send acknowledgement to this chain, right?
Yeah, well, I mean, yeah, that's definitely right. But what I was wondering is, like, is the idea that when you do one of these things, the acknowledgement getting sent back is implicit and transparent to the other side of the equation, to this receiving side? Like, is that
Well,
something?
I think that you cannot pattern match on this, right?
On the ACK?
Oh, or you mean that if you are using the regular receive, then you can pattern match on this special channel.
Definitely the receive can always pattern match, right? Like, I could, whatever came over Chan, in this case 5, would be pattern matched. I mean, this is a pretty simple pattern, but
yeah. But do you have access to this synchronization channel?
Oh, like down here, like, can I do something with R, you mean?
Yeah.
Yeah, I don't think so.
Yeah.
Is that what you thought?
Yeah, but I mean, because of that, I think that you will not have a COM.
Oh, really?
Because I'm thinking that you will never receive this 5 until the Chan receive this acknowledgement from you.
Oh, I agree with that. Yeah, like they happen
thinking?
simultaneously. Like we'll move on past the semicolon at the same time the discontinuation gets kicked off.
Yeah.
Yeah, I think that's right. But I still don't see why that would have to stop a COM from happening here.
Well, I'm thinking that this 5 will wait.
Yeah. I'm curious if we can construct an example that goes in the other way, where we do one of these new question mark bang.
I hate to be a party pooper here, but it's 12 o'clock New York time, and
Yeah.
the governance meeting is supposed to start now.
Yeah, okay.
It looks like not many people have showed up yet for that particular purpose.
Is it here in your room, Jim?
I'm sorry?
Is it here in your room, that
Yes.
meeting? Oh, yeah. Oh, yeah, sounds like they're coming in.
Okay, we have something from next time.
Yeah, that's right. We'll nix it here. Thanks for sharing that Rholang 1.1, guys. That was interesting.
Yeah,
Okay.
super interesting.
If you want to come back later, we can do that.
It'll probably be pretty late for me, but we're going to get together in the morning too, right?
Yeah.
Or in your morning? Yeah, cool. Tomislav, is your person you met coming tomorrow?
Oh, yeah.
Oh, wonderful. I'm excited. Okay, cool.
Oh, me too.
Tomislav, did I add you as a friend earlier? Did I get the right guy?
Oh, yeah.
Right. Cool.
Yeah, that's me.
Yeah, nice to meet you, Joshy.
Yeah,
see you
likewise.
tomorrow. Bye.
All right.